Hi everyone, welcome to Autodesk PowerMill, the complete course. So today we are going to start the new module, which is module number 4, and advanced finishing toolpaths and machining strategies. So this contains a lot of tool strategies here, and the first one is the 3D offset finishing. In this video, we are going to discuss one by one all these machining strategies, and all these machining strategies are related to finishing. The first one is the 3D offset finishing. The second is we are going to discuss about constant Z finishing, then corner finishing, then flow line finishing, parametric offset finishing, parametric spiral finishing, then pattern finishing, then profile finishing, project curve finishing, project line finishing, radial finishing, raster finishing, rotary finishing, and spiral finishing at the last. So we'll discuss all these toolpaths one by one, starting from the first one, which is the 3D offset finishing. So let's get started. So I'm using the Autodesk PowerMill Ultimate 2024 version, and we are going to start the 3D offset finishing. The first thing you have to notice that the toolpath strategies all we have listed here was finishing strategies. So before doing finishing operations, we have to perform the roughing operations. So in the previous module, we discussed all the 3D roughing strategies. So after these roughing strategies, we have to apply the finishing strategies. So let me show you and tell you how we can apply finishing strategies. And after that, we are not going to apply the roughing strategies. We are discussed only the finishing strategies. So let's go and give you an example of how first we apply the roughing strategies and then the finishing strategies in this 3D offset finishing toolbar. Let's go and go to File, Import, Example, and set example as cowling.dgk file. Click Open. So here we have a surface and we have a model already here. What I'm going to do is I'm going to create a block for that, because I'm going to apply the roughing strategy first. Calculate it. Okay, accept. Just go and create a work plane for that. Create work plane, orientated work plane according to the position using block. So I'm set as the work plane over on the top of this block. It is by default and set it mostly around the world. Click Activate. The block is set it aside. Just go and select the block again and calculate it. Accept. Just write the work plane and rename it as W1 for better understanding. Now it's time to apply the 3D strategies first and 3D roughing strategies. Let's go to Toolpath. Go to 3D area clearance. Let's select the model area clearance. Just give you an example how to apply first roughing operation and then after that applying finishing operations. First one is the model area clearance. I want to remove all that solid material from the surface. Create rough surface of that model. Just give you a name as model area clearance. Select the tool I'm going to set roofing tool as 12 millimeter flat end mill. Flat end mill. Set as tool number 1. Machine tool limits. Model area select as offset all, or you can set as raster, model offset, and vertex. Just set as a vertex tool. Set the torus 0.01 thickness. I don't need any thickness. Step over of 6 millimeters, and the step down is 1.0. For model, set tangent 1.0, all that by default settings. And just go to rapid. Select your work plane. This is work plane 1. I have to set the rapid moves, rapid clearance and plunge area clearance according to my work plane, which is I have selected here. Let's calculate it. So I just automatically set it the work plane and rapid moves according to the work plane we have set it. Just go to leads and links, set the links, scheme, incremental, set the gauge. Click on the feeds and speeds, set the feeds 5000 RPM, 1500 millimeters, cutting feed, apply feed 150, and scheme feed 3000. Set the coolant rate as flood. Click on calculate. So it's just calculating the model area clearance according to the strategies which we have applied is the vortex strategy. You can create the vortex strategy, either you can use the model area clearance or offset all, or the raster technology, or raster style. Also, you have to note that the calculating of area clearance toolpath depends upon the processing unit of your system. So you need a good processing unit system with a high RAM, high graphics units, and high processing capabilities. It's analyzing the toolpath. And it's created. It's got it. Click on close. So this is what we call the vortex style model area clearance. So just move all that material on the surface and it creates a rough surface of that model according to shape. Let's go to simulation. Click on the model area clearance. Click on the view mill set. I'm just going to show you how it just looks like. Let's go and click play. And you'll see that it's taking a 1 millimeter step down to remove that material. You can take a speed control and make it high. Speed up the process. As you see that it takes us 1 millimeter step down and take a rough cutting of that material and taking a vortex type cutting method. And just click on the end to end, and this will just simulate it in a fast way and cut down all that material. And just look how it looks like. And that's how it looks like, the toolpath. Just go and hide that toolpaths and see how it looks like. So this is the rough style and rough model area clearance. Now it's time to create rest material, and that's a rest material. We want to remove that rest material from the surface. Just go and create a toolpath and set as model rest area clearance. Just click on OK. Set as model rest area clearance. And we have to set the tool. So this time with the rest material, I'm going to use 8mm end mill. Set as offset model steps or step over is 8mm end mill I'm using, so I'm going to set 3.0mm as step over, and the step down is going to be 0.3mm. So you have to define the rest material. So we have the model area clearance is a toolpath which creates rest material on that surface. So we have selected the rest material toolpath, and here we have the model area clearance, the previous toolpath. Okay. So I just don't need anything to change. Just click and calculate it. So the cutting toolpath will move that all the rest material which is being shown here. So it says that the plunge moves is getting into stroke. So just go and click OK and move that things. Click close, and you see that it's not moving all that material. It just removes all the rest material which is being shown here. Just go to simulation, select your rest area clearance and play it. So just moving that all that material here. Just click on run and to speed up the process. So just going to speed up the process. And this is how it just looks like. So makes a better surface. And now it's time to create the 3D offset finishing operation. So let's get started. As you know that the 3D offset finishing operation, or all the finishing operation, is done after performing the roofing operations. Okay. So just go to toolpath, create toolpath, and go to finishing operation. You see the tab over here. And on that tab, you will see all the finishing strategies. There is a lot of finishing strategies here. Included 3-axis, 4-axis, and 5-axis. So what I'm going to do is, we are going to study about the 3D offset finishing. Just go and select the 3D offset finishing. Click OK. So named as 3D for better understanding, 3D offset finishing. Select the tool. For finishing operation, you know that we have to change the tool. We're not going to apply the flat end mill. We need a finishing on that surface. So for that purpose, I'm going to use the ball nose and mill. So here I'm going to use the 5mm DM. B stands for ball and M for mill. Make a diameter of 5mm. Go to machine, go to limits. If you have to apply some limits over here, so you have to define some limits that the cutting tool should be perform within that range. That's called the boundary. If not, then what you need is you have to go to the 3D offset setting and you have to create a pattern. So as you named it, the 3D offset finishing. So offset means the pattern you have selected and creates the offset of that pattern and cut down all that material and create a finishing toolpath on the surface. So I'm going to create a pattern. Click on here, create a new pattern. Just name as one. Go to curve editor. I'm going to select a composite curve over here. And just select it, did all this. So just go back, click here, just go around all that surface. I see that I'm going to select the corner edge of that. Click save, click OK. So the cutting toolpath will be definitely created according to the pattern which I have created. Click accept. So this pattern 1 is going to be used as offset. So it says that the direction of offset is from outside to inside, not from the inside to outside. It's going to be used as outside to inside. And the shape is going to be spiral, smooth. And if you want to set the maximum offset, you have to set the maximum offsets over here. But this time I'm not going to set the maximum offset, just uncheck it. Set the tolerance range, cut direction in claw milling, and thickness if you want, any. So I'm going to use the 5mm and tool, and you have to set the step over for that. The closer the step over, the closer will be the offset, and more finishing will be come over on the surface. So before applying the real toolpath, you have to define a limited tool step over here. So for example, I'm going to set the 2.5mm first to check how it actually looks like. And according to that, it will create a scope of that thing. You see over here that we're going to use that thing. So this is called the cusp height to determine how the step over between the consecutive segments. And this depends upon the closer will be the cusp, the more finishing will be a curve over. For example, I'm going to set the cusp height 0.01. So it will create a step over of 0.31. So I just want to calculate faster. For that purpose, I just selected as 2.5mm setting as a step over to create a cusp height of 0.372333. Just go to rapid moves. We have already selected the work plane. Go to links, go to feed and speed. And for the finishing operation, you have to set the spindle RPM much higher than the roughing operations. So for roughing operation, I just set it to 5,000 RPM. And for the finishing operation, I set it as 20,000 RPMs. With the cutting feed rate of 3,000. Because in the finishing operation, a very small amount of material is going to be removed. Set the coolant for better finishing. Go to flood. Calculate it. And you see over that it creates an offset according to the pattern which we have selected. And remove all that material on the surface. So I see that it creates a 2.5mm step over on the surface. So it shows that it will cover all that thing. Good. So this is how the finishing toolpath works. So let's go and simulate the toolpath. Click on the offset and play. And you see over there, this shows the cusp height. This is how the surface finishing will work. So as you know that we have set the step over of 2.5mm, which is a very high. So right now I'm going to change the step over. Go to settings, refresh it, set the step over, or you have to set these steps over or cusp height 0.05 or 0.0. I set it 0.03. Okay. Let's calculate it. You see that the toolpath is getting closer and closer, and the closer the toolpath, the closer will be finished, and more finish will be discovered. Close it. Now again go to 3D offset finishing, plate. And you see over here that finishing is occurs. The cusp height is going to be down. And this is how our surfaces looks like. So this is how we can say that 3D offset finishing works. That's it for the today's lecture. Hopefully you enjoyed. Thank you very much.